All right, guys, 1.5, we are solving multi-step equations again, but this time we are finally going to use that middle step from Don't Call Me After Midnight, because for the first time we are going to have variables on both sides. So go ahead and find your Don't Call Me After Midnight card, get that out, have it next to you, because we are going to reference it on every single problem today. So let's look at question 1. They started the problem for us, but they did not finish it. So I see that there is no distribution in this problem. There are no like terms. I have two x's, but they are on different sides of my line, so I cannot combine them. What I can do is move my variables using opposite operations. So just like I would get rid of a number, here I have negative 5x on one side and positive 9x on the other side. I'd personally rather have positive numbers than negative ones, so we're going to get rid of that minus 5x. The opposite of negative 5 is positive 5, so we're going to add 5x on both sides. Negative 5 plus 5 is 0. It's gone from the left side of the equation and just leaves 71. On the right side, I have 9x plus 5, which is 14x minus 13. So now I have variables on only one side of my equation, and that's what I'm looking for. So we moved our variables all to the same side. Now I'm looking for adding and subtracting. If I want to get x by itself, then that means I need to add 13 to both sides. 71 plus 13 is 84, and that equals 14x. We're multiplying x times 14, so we need to divide by 14 to get the variable by itself. 84 divided by 14 is 6. So 6 equals x. Okay, question 2. It looks like they did the problem for us. Let's just go through and check their work. First thing we look for is distribution. Nope. Combining like terms, let's see. Do we have variables on the same side? I see a 3x and a 5x, but they are on opposite sides of the line. Can't combine them. Because the variables are on opposite sides, that means we need to move things. So to move 3x from the right over to the left, it looks like we subtract 3x. So 3 minus 3 is 0. 5 minus 3 is 2. So 5x minus 3x is 2x. Variables are moved to the same side, so we're done with that step. Then we look for things to add and subtract. If we want to get this variable by itself, that means we need to get rid of that plus 3. We use a minus 3 on both sides. Negative 7 minus 3 is negative 10. And 3 minus 3 cancels and just leaves 2x. To get the x by itself, you cancel the 2 out by using division. 2x divided by 2 leaves x. Negative 10 divided by 2 leaves negative 5. So x equals negative 5. Number 3. Again, they started the problem for us. We have to finish it. Those arrows in the first step tell me that they did the distribution. They multiplied 5 times 1 minus u. That gave me positive 5 minus 5u. Now I need to go through and look for combining like terms. So if I have a 5u here and a minus 5u here, I can combine those, but what is that? 5 minus 5 is 0, okay? So I have 0 u's left over on this side. That's kind of nice. That means all I have on the left side of the equation is the number 5. 5 equals u plus 8. Because I got rid of all of the variables on the left side, I don't need to do this middle step, but I do need to look at what I'm adding. To get u by itself, I should subtract 8 from both sides, and that gives me negative 3 equals u. Oh, cool. I don't need to multiply this time. I'm done. U equals negative 3. Easy enough. Okay, number 4. 5 minus 7 times t plus 1 equals negative 10t plus 3. I am going to write in my steps, don't call me after midnight. They took care of distribution for us, distributed negative 7 times t and negative 7 times 1. Now we're looking at combining like terms. I do see some numbers here that I can combine on the left. Nothing on the right though, so this becomes negative 2 minus 7t equals 10t plus 3. Like terms are combined. I have variables on both sides, so I do need to move them. If I want to, I can move that 10 over to the negative 7, but personally, I prefer positive numbers. So I am going to add 7 to both sides and get rid of that negative. Negative 2 equals 17t. Whoa. Whoa, guys, why didn't you yell at me? I hope you were yelling at your screen. That was dumb. That was a bad mistake. Let me try that again. Okay, so this got to go because I did a bad thing. What did I forget? Yeah, I forgot my negative. That should be negative 10t. Okay, so we can fix this. Negative 2 minus 7t equals negative 10t plus 3. Again, same thing as before. I prefer dealing with positive numbers. If I add 7t to both sides, I will still be left with negative 3t. If I add 10t to both sides, negative 7 plus 10 gives me a positive 3t. That's nicer, so let's go with that. Negative 2 plus 3t equals 3. We have moved our variables to the same side. I want to get my variable by itself, so I need to add that 2 to cancel out the negative 2. 3t equals 5. And finally, to get t by itself, we're going to divide by 3. 5 does not divide nicely by 3. That's fine. We can leave this as the fraction 5/3. 5 over 3. Okay, let's look at the next problem, question 5, and this time I'm going to watch my negatives really closely. First thing I write in, my steps. Don't call me after midnight. DCMAM. First step is distribution, which they have done for me. How kind. 5 times 2 plus n equals 5 times n plus 6. On the left side, that gives me 10 plus 5n. On the right side, that gives me 5n plus 30. There are no like terms on the same side of the line. I have variables on both sides, and they're both 5n, so it really doesn't matter which one I want to cancel. It's going to work out the same either way. So to make this 5n go away, I subtract 5n, and I do the same on the other side. So 10, that cancels, equals, that cancels, 30. That's a problem. Is 10 equal to 30? No. And there's no variables left. So this is wrong. Like, this is just a factual, an unfactual, non-factual. This is a wrong statement. This is not mathematically true. So let's get an angry red pen here, and we're going to write false. 10 is not equal to 30. There is no way to make that true. So because our variables completely canceled out, we say that there is no solution here. It does not matter what I plug in, because no matter what happens, my ends will cancel out, and I'll be left with something that's bad and wrong. So there's nothing that I can plug into that equation that makes it okay. All right, let's try question 6. Let's hope that one's a little bit more friendly. So let's grab a less angry color, back to a nice purple. Write out my steps. Don't call me after midnight. Step 1, I distribute. 5x minus 35 plus 42 equals 3x plus 7 plus 2x. Step 2, let's look for some like terms to combine. So on the left side, I can combine my constants. Let's see, negative 35 plus 42 is 7. On the right side, I can combine 3x and 2x. So that's 5x plus 7. Ooh, I've got the same situation as before, where my variables have the same coefficient. So let's just see what happens. It doesn't matter which one I cancel out. So let's just subtract 5x from both sides. And this time that leaves me 7 equals 7. Okay, that's better than before. 7 is equal to 7, so that's true. So if 7 equals 7, no matter what, and my variables are going to cancel out because it's the same 5x on both sides, that means it doesn't matter what I plug into this equation. I could plug in any real number and it would be okay. All real numbers is my solution in this case. I was left with an okay, happy, true statement with the same number on both sides. So it doesn't matter what I plug in because 7 will still equal 7 at the end. Let's see, it looks like that is the end of these notes for today. Let's double check that. Yep, that's it. So I will see you tomorrow for solving literal equations.